Kasturi. Today I'm going to discuss this electricity chapter according to ICSE syllabus class 8. So in my last two videos I discussed about I was discussing about this electricity chapter. So in my last video I discussed about the pith ball electroscope. Now this today I'll start with gold leaf electroscope. Okay. So I told you the gold electroscope has a brass disc and a brass rod, to which the brass rod is attached into a glass chamber. Okay, and there are two golden leaves which are attached at the end of the rod inside the glass chamber. Okay, so now this electroscope can also detect, like the pith ball electroscope, it can also detect the charged or an uncharged body, or the body is it positively charged or negatively charged. Okay, so both of this can be detected by this electroscope also. Now gold electroscope to test whether the body is charged or uncharged. For this we need a electroscope and a gold leaf electroscope, the body which is to be diagnosed whether it is charged or uncharged. That is brought in touch with the brass disc of the electroscope. If the leaves diverge, the body is charged. Okay, and if the leaves do not diverge, then it is uncharged. See, from the picture also you can see that the first picture where the charged body is, the body is brought in contact with the brass disc of the electroscope, then the leaves are not diverging, though then the body is uncharged. So we deduce that the body is uncharged. And in the second picture you can see the leaves are diverging. So that means the body which is brought in contact is a charged body. Okay, Next is that whether the body is positively charged or it is negatively charged. Now for this we need to take a charged electroscope, charged gold leaf electroscope. Say it is positively charged. Okay. Then a charged body is brought in contact with the brass disc of the electroscope. If the divergence of the leaf increases, okay, see, the body which is to be diagnosed, that is also charged, but we don't know whether that is positively charged or negatively charged. So that charged body is brought in contact with that brass disc of the electroscope, or the charged electroscope. Say that electroscope is positively charged. Now if the divergence of the leaf increases, then what happens? Then we will deduce that the body is positively charged. Okay, now if the body, if when we bring the charged body in contact with the gold leaf electroscope, that is the brass disc of the gold leaf electroscope, if the divergence decreases, okay, if the divergence of the gold leaves decreases, then that means the body is negatively charged. Okay, if the divergence of the leaf increases, the body is positively charged, and if the divergence is it decreases, then the body is negatively charged. Okay, so this can be done by a negatively charged electroscope also. We say that it is a positively charged electroscope, but if it is a negatively charged electroscope also, this can be done, because the charged body, when it is brought in contact, if the divergence increases, then the body is negatively charged. In case of the electroscope, if it is negatively charged, okay, then the body which is brought in contact with the brass disc of the electroscope, if the gold leaves of that electroscope increases, then the body is negatively charged. Okay, and if the gold leaves, that means the leaves divergence decreases, then the body is positively charged. That is the opposite case. Okay, so what we can deduce, that there's some mistake in the this one point. Okay, so please ignore, it will be, and I'm sorry for that. The leaves will be, the divergence will, in the first case the divergence will increase, the body is positively charged. If the divergence decreases, the body is negatively charged. Okay, So depends on the charge of the electroscope. If the electroscope is positively charged, the the body, if the divergence of the leaf increases, the body will have the same charge as that of the electroscope. And if the divergence decreases, the body will have an opposite charge as that of the electroscope. Okay. I think you have understood this one. Now we come to atmospheric electricity. Okay, in 1749, Benjamin Franklin, an American scientist, concluded that the clouds acquire an electric charge which produces thunder and lightning. Now, what is lightning? Lightning is a dazzling bluish white light which is produced in the clouds. Okay, and what is thunder? Thunder is a loud noise that follows lightning. Okay, so this is the picture we have seen in the atmosphere generally during rain. We see storm and rain, we see this lightning and thunder. Next is this Benjamin Franklin's experiment. What did he do to deduce this thunder and lightning? Now, the thunder and lightning, no, it is the clouds have charge. What did he do to examine that? What is his experiment? So we'll discuss that. He took a kite which is made up of silk cloth. Okay. At the top corner of the kite, he fixed an iron wire about 30 centimeter long. Top corner of the kite, he fixed an iron wire. The other end of the wire was joined to the strong silk string. Okay, so the kite was made up of silk cloth, and the wire, the string which is attached to the kite, that is also made up of silk string. And he fixed a iron wire at the top corner of the kite. One end was fixed with the top corner of the kite, and the other end to the strong silk string. Now, at the lower end of the silk string, an iron key was tied. See, this is the kite. In the second picture, you can see this is the kite that is made up of silk cloth. That is strong silk string is attached to this kite. Okay. Now, one wire was attached at the top corner here, and another one was attached to the silk string. Okay. Now, this at the end of this silk string, a iron key was tied. He flew this kite on a day when there was thick dark clouds in the sky. During this time, he brought his knuckles near the lower end of the key, but nothing happened. Okay. Now, but during thunderstorm, when it started raining, he brought his knuckles again near the lower end of the key, and he observed that the string, and when the string got wet, actually, during thunderstorm, when there were clouds, nothing happened. When he brought his knuckles is a body part of his. Okay. When he brought his knuckles to the lower end of the key, nothing happened. But during thunderstorm, when it was raining, the string got wet. Okay, and that time when he brought the knuckles, he obtained number of sparks between his knuckle and the key. Okay. Now, explanation of the Benjamin Franklin experiment. What this experiment explained. Okay, what did he want to explain with this experiment? During a thunderstorm, clouds gets charged due to friction. First point, that when there is a thunderstorm, lots of clouds are moving around, and therefore what happens, they get a friction between them, and that produces charge in the clouds. This charge flows through a metal wire during the wet string, and then to the metal key. Okay, when there is rain, the string gets wet, and that time what happens, the charge flows through the metal wire of the kite that was attached on the top corner of the kite, and the other end was attached to the string. So that through that metal wire, the charge flows through the metal wire, through the wet string, to the metal key. Okay, in the iron key, the charge gets collected. Okay. Now when the knuckle comes near the key, it gets oppositely charged. Okay. The spark occurs between the unlike charges of the key and the knuckles. Okay. Now, how clouds get electrically charged? Due to the heat of the sun, that's a water cycle which we had studied earlier in our earlier days, okay, in our lower classes. There, that is during the heat of the sun, the warm airs and the water vapors rises up. The cold air above sinks down. The air molecules during this process rub against the water molecules, or the cold current of the air rub against the hot current of the air, and due to this, there appears a friction. The electrons of the air get transferred to the water molecules and vice versa. That is, water molecules also, the electrons of the water molecules also get transferred to the air, and electrons of the air get transferred to the water molecules. And all this depends into the atmospheric conditions. Okay. Now, when condensation takes place, that is when the clouds are formed, okay, then these clouds have a huge amount of static electric charges, that is positive and negative charges. Okay. So what happens during lightning? During a thunderstorm, when a charged cloud passes over the earth or over the other cloud, it acquires an opposite charge by induction. Okay, a spark may occur between the two oppositely charged clouds, or the charged cloud and the earth, and that is known as lightning. Okay, so in the lightning, what happens? A spark which appears between two oppositely charged clouds, or the cloud and the earth, that is also oppositely charged. Okay, that spark is known as lightning. Okay. Now, this causes very dangerous and serious effects on the objects. It can kill humans and animals, and even cause fire and destroy buildings. Okay, so I'll stop here. I'll continue with the rest of the chapter in my next video. Please go through this. If you have any doubt, please do write in the comment box. And how are you all liking these videos? Please do let me know. If you want any, you may give suggestions to improve my videos if you not liking it, if you're not liking it. Okay, so if you are liking it, press the like button, share with your friends, do comment, and do also subscribe so to get the notification of my next video, and that can also produce me some enthusiasm to produce you some good videos for you which can help you in your studies. Okay, and I'll be launching a website soon that I told you earlier also. I'm telling this in my few videos. Okay, so please wait for that, and thank you for watching. Thank you.